boys and girls. Today is Friday, January 8th, 2021. And as you know, I am doing reading tests. So your science and social studies lessons will be asynchronous today. That means that you are doing them on your own. So the first couple of slides of your science lesson are a review. We've already talked about these things. So it says in chapter 1, we made the claim that something went wrong with the electrical system in Ergstown, and that is why they keep having the blackout. Next, we are going to investigate the electrical devices that are part of the electrical system. This will help us better understand what happened with the electrical system during the blackout in Ergstown. These slides are just review. We've pretty much done this already the week before break, but I just want to kind of refresh it with you guys. So we're going to focus on the chapter 2 question, which is what makes the devices in Ergstown output energy or fail to output energy? So we've discovered that electrical devices have things called inputs and outputs. So for example, in this simple electrical system right here, we observe the buzzer has electrical energy as an input and sound energy as the output. Electrical devices always have electrical energy as an input form. So the word electrical, see, it matches. Output energy forms, so that's the energy that they produce, can come in the form of light, thermal, motion, and sound energy. For example, if I were to plug a light, an electrical outlet of my light plug into the wall and turn it on, the output energy that it's producing is light energy. If I am going to be blow drying my hair and I plug my hair dryer into the wall and turn it on, that's heat, right? That's heat energy or thermal energy. For example, motion energy would be plugging a fan into the wall. Sound energy would be like plugging in a radio or something like that, right? It produces sound once you plug it in. Today, we're going to investigate this question. How do devices have so many different output energy forms when they are plugged into the same electrical system? So we read about the stove and we read about the music player, right? Both of these devices get plugged into the same electrical system. Both devices have electrical energy as their input. However, their output is different, right? Their output is different. What they produce after they've been plugged in and turned on are different types of energy. The radio has sound energy and the stove has thermal energy, heat. We can say this in another way, such as the radio converts electrical energy into sound energy, and the electric stove converts electrical energy into thermal energy. All right? We talked about when you rub your hands together, what happens, right? We produce thermal energy. This is a review. We convert motion into thermal. So this is the new stuff for today. You guys are going to be using the simulator again to investigate this theory more. So we're going to explore how devices convert energy from one form to another using the simulation. And the instructions to use the simulation are also in your Google Classroom assignment. You're going to watch the video of the sim on the next slide, and you're going to notice how the sim shows energy inputs and outputs. So on the next slide is the video, right? You're going to click that little play button, watch the video, and then you're going to notice the labels above the system. So here is our system, right? These are, whoopsie, sorry about that. These are the labels: light, electrical, motion. All right. These show the forms of energy in the system. For example, the solar panel has light energy as an input and electrical energy as an output. The motor has electrical energy as an input and motion energy as an output. Okay. Input, output, input, output. So notice the small red lines leaving the system. So that's these things over here, right? This is your key. These dots are light, the wave is thermal, and like the little sound bars indicate sound. The key shows us that the red lines represent thermal energy. So this flywheel right here, see the little red squiggly lines coming out of it? That means that the energy output is thermal for that part of the system. You can also see in the graph of energy transferred out that thermal energy is leaving the system, right? It shows you right here in this graph that it's the thermal energy that's leaving the system. So you're going to work with the sim. You're going to create your own system that's similar to the simple electrical systems with the LED and the buzzer. You're going to use the simulation, the online simulation, and you're going to be filling out this chart. You're going to record your observations about the system that you built. And here is where you can do it. We'll think about the system with the motor and the flywheel we just saw. We're going to use that one as an example. So the system name is the solar electric flywheel system, right? We list the parts of the system: the sun, the solar panel, the motor, and the flywheel. The electrical device is the motor, and the output is motion energy and thermal energy, right? So you are going to be doing that for your own right here on this slide. So this is slide number 28. You're going to create 2 systems and you're going to fill in this. You're going to create your systems in the sim and record your notes. If you click on the sim, it will take you to the sim. All right. Good luck, guys.